welcome everybody to the event. I have sort of the sort of nice job of doing sort of an introduction to virtual, and I will, because of the project has a lot of elements of augmented reality, and they are essentially born together. So what I'm going to do is just have a brief sort of about 13, 14 minutes here, just to discuss sort of a little bit of short history about augmented and virtual reality, discuss some of its possible futures, and also why this sort of technology is going to become pretty much one of the main ways that you actually use computers in the future. So it makes a lot of sense to be connected with the project there. So again, it's going to be a little bit about the initial concepts, history of how we've gotten here, and a few guesses of where it's actually going. So for me, one of the sort of ultimate ideas of virtual reality, I was sort of first introduced to virtual reality myself as a child when I was watching the Channel 4 Christmas lectures, and they had a fantastic little demo on virtual reality at the time, and I got into it and just found this was just an amazing technology. Decided to do computer science, and then one of the best summations I've had this is the kind of father of computer graphics, Ivan Sutherland, of what we want, this ultimate display. And the ultimate display would, of course, be a room which with the computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in. Handcuffs displayed in such a room would be confining. And a bullet displayed in such a room would be fatal. With appropriate programming, such a display could literally be the wonderland into which Alice walked. So as a VR researcher, the possibilities of what we can do with this technology are endless. And obviously its use for education is going to be one of the primary focuses that will be discussed by the speakers today, and just show what we can do. But it is this view into what previously would just be a mathematical equations into an actual world that we can actually be inside. Now, there is a lot of sort of also stigma around VR that we don't want necessarily that we're all going to be plugged into a matrix, that we're not going to be engaging in the real world. So for me, the sort of dream of virtual and augmented reality is that shared space where this just becomes the next stage in human-computer interaction. And instead of the laptop that I'm sitting in front of me now talking to you guys, we would be able to have a virtual room that we would just nicely enter. And there's various technologies, things like AltSpace, that already allow a lot of this to be done already. I myself even have a startup in the area, a meeting room for enterprise systems. So we want to have this different world that we can get to. And a lot of the terms that you're going to see today, it's something to kind of give you an idea of how to understand them. And one of the best things with the reality virtual continuum that Milgram helped develop in the early 90s. And this is the concept that if you think we have a real world that we're all hopefully very used to, and as we add virtual components to that, so if we were wearing special glasses that we could see in, we get an augmented reality world. And one sort of famous example I always use, kind of film examples when I teach, is things like Roger Rabbit. So this idea of a cartoon world coming into our world and us being able to interact with it. And as we add more and more virtual elements, we get into pretty much a mixed reality where half of the world around us is virtual, the other half is real. And as we go into what academics call augmented virtuality, this will be us entering in that cartoon world, where there'll be elements of the real world spliced in with elements of the virtual. And then finally, we get to a place on the right-hand side of the continuum where everything is virtual, everything is computer generated, and we are completely immersed in that body. So the sort of matrix of virtual reality there that you could imagine. So there is many starting points to think about where we got to our current technology of virtual reality. All through the 19th century, people had started developing with pieces of film, and even back at the beginning, they had simple stereographic picture viewers. So having two images just put up to the eye, two paintings, that you would see a 3D object. But I always like to use the World Fair of 1901 with the Cineorama. This is one of the first fully immersive experiences where somebody had recorded a balloon ride over Paris, and essentially it was all black and white, and they built a gigantic auditorium, all just wooden panels, silver nitrate, which will become important to actually play back the footage and allow people to go into this fake balloon and actually have this virtual experience of flying over Paris. And this was over 100 years ago. Now, unfortunately, even 100 years ago, health and safety officers existed. So unfortunately, this was closed down within a day when the health and safety officers realized that approximately 16 or so projectors produce a lot of heat. And unfortunately, the actual material within the screens had a tendency to go on fire. So they actually closed this down. So it was mostly only there for a day, but I love the fact that it was only there for a day. This wasn't a large scale exhibit, but it showed that you could have these sort of virtual worlds. And all throughout the early part of the 20th century, people were thinking about using film and being immersed within it. Obviously, computers hadn't reached a stage where they could generate the 3D graphics necessary to be immersed in these environments. So things like Morton Hagen's Cineorama, where somebody would stick their head into effectively a little arcade machine and go on a virtual ride through San Francisco with haptic feedback and sort of being jolted around. But eventually, in the 60s and late 60s, computer graphics was finally born. One of the first examples of this was from Ivan Sutherland, who becomes important because he also developed, his team in Utah, also developed the first proper head-mounted display, where we essentially see what we consider drawing. And a mouse at that point wasn't widely used. In fact, it would be a couple of years before it was fully invented. So laser pens, which we would consider a more modern invention, but even back then, they were tracking pens just to be able to start drawing basic objects. And this also inspired things like object-oriented programming, because the idea is you draw this to a piece of memory, and then you'd reference from that memory for those drawings. But finally, in the late 60s, we finally got that first virtual reality headset. Now, the tracking system was referred to as the Sword of Damocles, but most of the time the headset ends up apocryphally being referred to that. But there was a great talk by Ivan Sutherland about 2 years ago, which SIGGRAPH sponsored, where he actually tried to explain that like the name of the headset was not the Sword of Damocles, it was just the tracking system. And this was because the simple tracking system was so heavy that essentially if it fell on you, and they were worried about bolting it to the ceiling, that it would actually kill the person using it. But the first head-mounted display was both a VR and AR headset, because the actual concept of breaking these ideas apart didn't even exist back then. So all this actually did, and all the observer is seeing there, is a very simple cube that the user can move their head and see around and has a full 3D effect. So this began this sort of era of virtuality research, where multiple universities started researching these technologies, and people started finding different use cases for them. And again, at the exact same time, in terms of filmmaking, this idea of us going into virtual worlds, like things like Mary Poppins, began to become something that the general public just became accepting of. And there was a lot of art exhibits at the time in the 70s, and the actual term virtual reality hadn't really been coined by Reinhold Gold's book yet, which I should have brought as a prop. I have one of the first editions downstairs. So people actually had multiple terms for these computer graphic generated worlds. And virtuality wasn't until that book that Reinhold, when he visited a lot of different labs, and Giron Lanier actually coined that term and used it, popularized it. So things like shared reality, artificial reality, and people would have used different ways of projecting like basic, what we consider basic webcams today, getting outlines and silhouettes with people and generating all these sort of weird environments and art projects that would have existed. So it took time till we actually got to a stage where we consider things where virtual reality is. And Hollywood at that stage was also thinking about that cartoon characters coming into our reality and sharing that as well. And then finally, in the 90s, HMDs were still very expensive. The field of use, so what you'd actually see wearing these virtual reality headsets, was actually quite limited. So Cruz-Neira's group in Canada came up with the concept of a cave based on the sort of Plato's allegory of people who leave this cave, who've lived in a cave all their life, see the real world and its splendor, come back in, and unfortunately try to explain to their fellow cave dwellers what they saw, and everybody thinks they've gone mad and unfortunately kills them. But the idea of a cave environment was some of the first cases where we could fully immerse somebody in a virtual reality space. So they could go into these virtual reality spaces, and all of the walls, so essentially your left, right, and front, top and down wall will be covered in virtual reality. And this started allowing virtual reality to be researched widely a lot in psychology, and also from the commercial world, especially when people were looking at geology. So a lot of petroleum companies actually found that they made more money because people using these interfaces could find more oil. At the same time, and something that is beginning to happen in places like Boeing, helped coin the augmented reality headsets, and they gave the first kind of patent towards that. And we started thinking, and researchers started thinking about what we could do with this technology. Things like medicine, that you could actually, let's say, see, visualize an ultrasound, which is an area that our lab in VR lab is still using for anatomy. We're starting to help train both in human medicine and veterinary students using these tools. One of the problems is we always thought we could just give this to specialists, but actually, ironically enough, they can't actually use these tools because they are trained so well in 2D representations that actually it's not a help. So you want to train the students first. And all through the late 90s, people started using things like our toolkit to start placing 3D objects in our world using markers. And nowadays, using things like ARCORE and ARKIT, now our simple phones actually are now our windows into our augmented and virtual reality worlds. Of course, that's not to say virtual reality, of course, has finally kind of come, and consumer headsets are now finally there. So things like the Oculus Quest and the Pico, for instance, have allowed consumers basically to start using this, which is fantastic. All during the lockdown, I had friends asking me, is it the right time to get a VR headset? And I was like, yeah, it's 300 euros. Go get it, and we can go play a game online. And from researchers, we have such advanced software frameworks such as Unity and Unreal, where these game engines have just opened it up that it makes it incredibly easy. So for instance, I teach a games development course here in UCD, and I quite literally tell the students that they just choose a game engine that's well supported and go make a game. And I will only teach them about the game's development aspect. My assumption is there's so many resources on YouTube and everything to learn that, and at first they think I'm mad, and that it's going, by the end of it, they're going, yeah, that was really easy. I'm like, yes, it was. So where, I only have a few minutes, I know, to finish up. So where are the possible futures of where this can go? Because this can become fundamentally a new interface for us to use the world. And obviously that comes, any new medium, especially a very rich and powerful medium like this, has good use cases and also bad use cases, because you could trick people to seeing things that aren't there. But hopefully when we talk about the CCAP project, it's about informing the public, about empowering them to be able to see this data and understand this data in a way that normally maybe only a professional could do. And one of the reasons I always think that VR will succeed in AR is just pure efficiency. The laptop that I'm on, the computer that's running here, that display requires an incredible amount of computation and just raw power to do it. But just like with speakers and headphones, so the headphones I'm using use nothing. So as we miniaturize this technology, and eventually we get it into the form of contact lenses and even just plain glasses, we can actually get to a stage where this becomes more energy efficient. And especially looking at cloud computing and what we also refer to as sort of fog computing. So a lot of people talk about 5G and VR and AR. And what they're really meaning is that we can have a stage where the device that we're wearing is quite light, and we've outsourced that computation. Now that could be done in your own home using your home server, or obviously if we're out and about and 5G becomes real, there is a possibility there of streaming that as well on it. But again, we don't want a VR virtual world stuck in virtual reality. What we would like is a world where this is an integrated part of our world that we go through. So it's going to be our choice at going through that. And just leave you it. So I run the VR lab in UCD.